could do all except number 3.
Even only 4.
Still. You're still sick.
But I don't know if right or wrong.
We'll find out now. Yeah. Okay, do you have the first question there?
Yeah, start.
We'll just wait till the writing pad opens.
What do you wear?
I don't know. Oh, did you see my costume from last year? Oh.
They told me about it, but I didn't.
I'll show you it.
What's Dumbledore?
No, that's Harry Potter. No, Gandalf.
SpongeBob. Anna told me.
Lord of the
Anna told me
Rings.
there was Dumbledore.
SpongeBob SquarePants,
So
huh?
it's, Lord of the Rings?
Kind of, yeah.
Okay.
Who's this? Hey, what are you doing here? Come join us. Are you dropping my lunch by? Is this?
Yes.
They're notebooks for your subject.
I had brought.
You bought some, did you?
Yes, I bought. I finished. But
Okay.
the files I could not see it.
All right, okay. Do you want to take those home anyway, and you can use
Thank you.
them from January,
From January.
whenever you finish using those?
This I bought this from 5 days, 4 days, something
Yeah.
like that.
Okay.
Just take it and then give it to us, man.
Okay.
Thank you.
Okay?
Thank you. Thank you so much.
Okay, you're welcome.
Thanks as well.
See you later. Sorry to interrupt.
There it is.
Why not us?
So bad. Okay, that's positive.
Easy.
Yeah.
Where are you?
That's it.
That's it.
This is
Oh,
you.
nice.
Is it on Facebook or?
I think it's on Facebook.
Okay.
You should take it.
But it'll,
Okay.
the lesson's recorded, so it'll be in the video.
1 second. You said that we must pass math and physics.
No, I used the modal verb shall, not
No,
must.
it doesn't mean.
It doesn't mean must. No, I didn't say you must pass or you will pass. I said you shall pass.
You must.
You should pass.
You should pass.
Yeah.
You must write.
Praise the Lord.
You will pass.
No, because some of you will not.
At least you changed the quote a bit. I mean,
A little bit,
positive, yeah. You should
It's
not-
super cheap. This I found in the garden. It fell off a tree. This is actually a rain jacket. This was like €5 and the hat was maybe €2.
It's nice. Yeah, looks really good.
I like
But
it.
you look like an old man in the picture.
And then I did some photoshopping,
Oh.
Yeah.
making it a little more
Really good
exciting.
Photoshop. I'm just doing this right now. I mean,
Yeah.
I'm on it, working on it.
So I don't know what I'm doing this year. I'll think of something. I tried to make the costume less than €10. This is the key. All right, let's have a look at the questions then. Have you anybody decided what they'll do?
No, I
No?
think I was thinking about SpongeBob and I said.
SpongeBob.
Yes.
You should be SpongeBob. I like this idea.
Yeah. Can be SpongeBob.
You going to dress up?
Yeah.
As what? Which? Great. Anyone else?
No.
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 Today?
Well, not today or on Monday.
No.
Maybe.
No.
Monday.
Holiday.
Yeah.
Monday is
We'll
actually
study.
Halloween.
It's already, you know.
Yeah.
It's
Well, think about it. Think about it.
Maybe.
Make sure you show us a picture. Are you going to dress up today?
Yeah.
Oh, great. Oh, you have it?
Yeah.
Oh, fantastic. Great. You can be a physics witch. All right. What's number 1 there, so?
A pendulum starts at its amplitude.
Yeah.
It is swinging back and forth. It swings out a distance of 5 centimeters either side of its equilibrium.
Okay.
It takes 0.5 seconds for each swing to fully complete.
Yeah.
How fast is traveling after 5 seconds?
After 5 seconds.
Yes.
Fine. Okay. So this is simple harmonic motion because if you look, the ball is going left, right, left, right, left, right. So now, is this what you mean, Iyad, about does it start from the outside or the inside here?
Yeah.
Can you read the start
It
again?
is I think from the outside. That's it, of course.
Either side of its equilibrium. It takes 0.5 seconds.
But what did I say? I said a pendulum is pulled, or?
A pendulum starts at its amplitude.
Great, so there you go, it starts on the outside then.
Okay.
Yeah, so that means you know that x equals a
Fine.
cos
X equals,
So it's
omega t
that's,
for x, but I don't want x,
you
I want v, and
Yeah,
remember v is the opposite, yeah.
Okay.
Now actually, technically speaking, there's a minus sign here, but I'm not too worried about the direction, I just really care about the speed, so I won't worry about that. So this will equal 0.05 sine. Now, do I know the t? Yes, I say after 5 seconds. Do I know the omega?
No.
No, but I can easily get it. It's 2 pi over t, which is 2 pi over 0.5. What's that?
12.56.
12.56, is it? So I'll just put in 12.56 here. Whoops. What mode should your calculator be in?
Radian.
Radians. So what do we get here? 0.05.
There must be 12.56 one more time. I mean,
Oh, sorry. Thank you. There's an omega
The
here,
omega
isn't it
sign.
here? Yeah, thank you. So I should have here 12.56 as
Oh,
well.
by oh.
You're giving me the final answer? Yeah, 0. Point.
O2.
Yeah, but and
Me
I
just.
have to ask
I
one
don't
thing.
know why
Okay.
minus a. I also write here is minus a because the answer is minus, so I give minus.
Yeah, really the formula has minus in it, but it depends because I said it starts at the amplitude.
yes.
From the center.
Yeah, but of course
Oh,
it could have started here.
Yeah.
You know, the minus is not so important as long as you make a choice at the start. So for example, if I call this plus and this minus and I start at the plus, then this should be minus. But if I started at the minus, then this would be plus. But it really doesn't matter as long as you use the same for the whole question. Remember I said often the minus is there just to show that it's an opposite. You remember in the acceleration there's a minus, isn't there?
Mhm.
What is it? A equals minus omega squared s.
Yeah.
Yeah. So often the minus is just to show it's in the opposite direction. Look, watch. Look. For example, if this is here in the positive, it starts in the positive. Everybody look, please. If it starts in the positive, is it going to move left or right?
Left.
It's going to move left
To the minus.
to the minus. So its velocity is minus. But if it started in the minus, it's going to move to the right, so its velocity is positive. So I'm not worried too much in this question about the plus or the minus, because it depends if you start on the left or the right. But you can always work it out if you just think carefully about it. Okay. Let's continue.
50 gram.
Sorry, yeah, Mir, you had a question.
So when it's sine omega t, so omega t is in the angle. Or
Yeah,
t
this
is
is-
different from omega. Like
No, you're right. This goes inside.
yeah,
as an
because
angle.
there were a little bit different.
Yeah.
If we do it.
Yeah, you might want to put brackets around it.
Oh, you mean you could
The omega t goes into the sign then. Yeah. Okay, we're good. Look at number 2. Okay, number 2.
A 50 gram mass is put at the end of a spring.
Okay, so we have a 50 gram mass at the end of the string. Yeah.
The spring is at rest.
Mhm.
A girl pulls down the spring at a distance of 10 centimeters. She releases and the spring starts to bob up and down. The
Great.
time taken for each to complete is 0.75.
Right. So this is clearly an outside one because she pulls it down and it starts here and then it goes up, down, up, down. So here the amplitude is 0.10.
Yeah.
Okay. And what do I ask for?
Many things. Find the omega first.
Find the omega first. Okay, so omega is 2 pi over t,
8.38.
8.38
Yes.
radians per second.
What,
B?
what is the acceleration after 1 second?
Right, now, did I give you that formula?
Yeah.
Acceleration with the time in it?
S,
It's minus omega
One.
square s.
Yeah, but I didn't give, you don't know
No,
that.
we do, yeah.
1 second.
That's seconds, yeah.
With time, wait.
No, we don't have.
We do.
Now listen, the formula, look, the formula is A equals minus omega squared s. But I don't tell you the s, I tell you
T.
the t. So you need to first find the s. Do you understand?
Omega,
Yeah.
A is equal to omega square s
Yeah.
minus.
Oh no, not this again. I was just talking about this 5 minutes ago. I said the plus and minus is... Oh,
No, so
my
the
heart.
omega
The plus or minus is not important.
I know.
No,
Yeah, we
listen.
have been given.
Listen. All these formulas have a plus or a minus in them. It's usually not important, and usually you have to decide if it's a plus or a minus for the question. Okay? So the formula I gave you had a minus in it, didn't it?
No.
Yeah.
Yes,
Yes.
it did. You wrote it down, didn't
Yeah.
you? Yeah, it had a minus in it.
Yeah.
Okay.
Yeah. Now, we need to decide if we have the minus here in this case. So, when we look at the motion, does it start in the plus or does it start in the minus? It starts, well, it depends what you want to call plus or minus. So, well, up and down. So usually we call up plus and down minus. Yeah.
So it's going to the.
So it's going to the plus. So the acceleration is positive or negative? Positive.
Yeah.
So in this case you could call it plus if you wanted to. But if you prefer, you can call this part plus and this one you can call minus. So it's going into the minus, so the acceleration is minus then. But it's your choice. It's
Do I
your
have to
choice.
clarify then? Or do I just write?
I think if you just wrote a plus minus on your picture like this, it's enough.
Okay.
Yeah. So which do you prefer, the plus on the top or the bottom?
Plus on the top.
The plus on the top. Okay. So if we put the plus on the top and the minus on the bottom, it means it's moving into the positive. So the acceleration is a positive then. Wait. It's okay. It's okay if you did it the other way. It's okay. Yeah. Now, wait, listen. But now you have to be careful with the other formula. So does it start on the inside or the outside?
Inside.
Outside.
Out.
Out. So x equals a cos or sine.
Omega.
Cos omega t. But because it's starting on the minus, at the very, very beginning, what's the x? X equals, this is the x now. This distance here is the x. At the very beginning, what is it? Come on.
0.
No. Here, in the center.
Five.
No, it's minus.
Read.
It's minus.
It's a 5?
Minus 0.5.
No, where are we getting this 5 from?
Minus 0.5.
0.05. 0.10. Okay.
Yeah, minus 0.10.
Okay.
Why minus?
Because
Because
it's
It's down.
going
Yeah.
down.
So that means in this formula, you need to put in a minus. Because it's starting in the minus. Yeah? Now maybe you don't like that. Maybe that's confusing you. If you want to switch these back to normal, then you need to call this one plus and this one minus then.
So this will be the same
The
answer.
same answer, yeah.
I'm still confused with this x formula.
Can I just interrupt you?
This formula, yes.
Why is it x? What is x in this?
Displacement from the equilibrium.
Okay. And
Oh, sorry, yeah. Sometimes for physics we use x for this problem, but I should be using s. I can't remember what I used in the note. Was it x or s?
last
It's
lesson.
Yeah.
Yeah. It was s, okay.
S.
I'll use s then. Yeah. Mir, if you're looking in physics books, some books use X, some use S, some use delta X, and some use E.
I think that for displacement S is most.
Yeah, I should try to stick with using S, but this and this are also very common. E stands for extension. Delta X stands for small displacement. X is just displacement, and S is also displacement. And actually, you can also use OR as well. Okay, I'm just telling you this.
Okay. And what about outside? How do we know the spring is going down?
No. It's outside because the ball is pulled to the outside and released.
Oh, okay.
Inside is split.
Like, okay, I'm clear now.
Are we clear?
Yes.
Right. So what's the S after 1 second? 0.05 meters. Right, so now we can get the acceleration. It's omega squared s. So that's 8.38 squared times 0.05. Thank you. 3.511 meters per second squared. Okay, what's next, Iyad?
Sorry.
Yeah, it's okay, yeah.
What's the first force after 1 second?
Well that's easy, because F equals MA. And what's the M?
0.05.
Yeah.
So,
kg.
kg. So in total, I just multiply my answer by 0.05, so I get 0.176 newtons, correct?
Yes.
No. Wrong, incorrect.
I think the question is asked about PE.
Potential energy? No.
Wait, why not?
Why not? Yeah, why not? Oh wait, sorry, no, it is right, sorry, it is right, sorry. I was thinking of someone else in my head. The question said, what is the net force? That's fine, yeah.
You're thinking of the total force?
No, net is total. I was thinking the force provided by the spring. Unless that's the next part, is it?
It's the last thing.
What's the spring is provided?
That's what I was thinking of, yeah, okay. Wait, that's E.
Yeah.
What's D then?
It's the force upwards or downwards?
Oh, okay, well, is this up or down?
Down.
Down. Because it's going up.
Oh!
Up.
Huh?
Thank you.
Down. Why?
Wait,
Is this
being pulled.
positive or negative?
Positive. Well, actually, I've got a minus number here because I did it the other way around.
Well then, but you called up minus? Or you just made a sign mistake?
I'm gonna find it.
Okay.
Excuse me, can I go to the toilet?
Yes.
This is part of our class. This is stuff.
Can you get 5? Say hi to Adnan. I'm sure he'll be downstairs smoking. He is smoking. I know he is. He's going to come back smelling like cigarettes. You all know I'm right.
Why the boys like smoking?
Because they're stupid. That's why. They're stupid boys. That's why they like smoking.
It's a boy thing now?
Well, do any of the girls in science smoke?
Many.
Many?
I've seen many.
In the bio class?
Yeah.
That's terrible, because they're supposed to be doctors.
Yeah, it doesn't make sense, does it?
Doesn't make sense.
Good doctor.
Bad doctor.
They say
Bad.
that smoking kills, you slowly. So they are saying we are not in a hurry to die.
Wait, okay. Alright, yeah, okay, alright. So they want to die slowly. Yeah, okay, fine. As you wish. Alright, so the last part, E, is what is the force provided by the spring? Now you might think the answer is this, but it's not, because this is the total. So watch. When you look at the ball, there are actually two forces on the ball. What are they?
The weight.
The weight, which is 0.05 g, and the force from the spring. This number here is not that. This is the total, correct. What you're saying is 0.176 equals F spring minus 0.05 G. Remember, Newton's second law is for the total force. Remember that. So, 0.0176 plus 0.05 times 9.81.
It won't be F plus mg.
It will be. This plus mg. Yeah, just take 0.508 newtons. This minus this is equal to 0.176 newtons. That's the total. The total. I don't know if anybody got that. That was a little tricky. Did you get this? No. Andy? No. Anybody?
I got the A wrong, so this is...
Yeah, but did you think about doing it this way?
Yes.
Oh, good. Okay. Help from Amanda, was it?
No.
No.
You know what I did? I do the first question and then I see from your video that I'm doing it in the right way. Then I do second by myself and then I check yours.
Okay. Okay, good. Okay.
That's how I watch it. So.
Yeah, okay, good, good.
Okay.
Right. Is there question 3 now? Is it?
Yes.
Yeah. Now this is the one you said was difficult.
I don't know.
I don't know. Is it the English? Is the English the
No,
problem?
it's not.
It's not her time.
No, you don't like this one, is it? What is it? What is it, Ian? Go ahead.
A 100,000 kg train.
Ah, the train. Okay, 100,000 kg train. And this one, the train has a bumper on the front.
It has a soft bumper.
Yeah.
The bumper is to absorb any shocks. When the train is parking, its bumper hits the wall slightly. It takes 250 milliseconds for the bumper to fully compress 2 centimeters and a further 250 milliseconds for it to decompress the same 2 centimeters. When the bumper is fully depressed, it has potential energy stored in it. How much energy is stored in it? And where did this energy come from?
It's a great question because it's kind of a real sort of engineering question. If you've taken, this is a train by the way, I can draw that better. It's a 100,000 kilogram train.
You made it like a cargo train.
Now it's a train. We'll make it an old-fashioned train. We'll call it number 1 then. Yeah, exactly, yeah. Right. So, you know on the front of the train, they often have, like in a car, a little bumper.
Yeah.
And this bumper is for when the train, you know, it slowly comes into the station and it just maybe gently just bumps into the bumper, you know. So, what we're looking at is what happens here. So, I don't have anything like this, but like with my hand. So if this is the bumper, and this is the wall, the train comes in, and then the bumper hits the wall, and then it compresses, and then decompresses then, yeah. So it comes in, and then it hits the wall and decompresses, compresses, and then decompresses. So this motion here, good cigarette?
No, I know. Oh my God, no, I stopped when you asked me that time. I didn't go for a cigarette.
No, why are you going this way? Oh, whatever. No, it doesn't matter. Continue.
Like, which way?
No, this is continue.
Oh, Mahmoud is not here.
Yeah. Right, so this motion when it hits the bumper, compresses, decompresses. This motion here is simple harmonic motion. Now it might be hard to see, so I'll try and draw it a little bit better. We picture this is the bumper, and then it compresses a bit, and then it decompresses, yeah. Do I tell you how, yeah, is that okay? Yeah. I tell you how much it compresses.
2 centimeters.
2 centimeters. So if we picture like here to here, and then here to here, it moves back, I said 2 centimeters, and then here it goes back to normal then.
Yes.
So what's the amplitude?
1.
Yeah, now you see,
0.1.
yeah, we'll have to, I think this might be a little bit easier if we think about it as a spring instead of a cushion. So it hits the wall, and then it goes back 2 centimeters. Can you see that?
Yeah.
So it goes back, and then it turns back down. So the motion is like this. If I try and draw it here, it goes back 2 centimeters and then out 2 centimeters. So the amplitude actually is 2 centimeters, because you're only looking at half the motion here. You know, it's like the pendulum. It swings out 2 centimeters and back 2 centimeters. You never see the other half of it.
Oh, okay.
Yeah. It really, if it could continue, it would go back the other direction. But it can't do that because it just comes in, compresses, and then decompresses. But it's not going to continue doing this. It's not like a spring. So you only ever see half of it. Yeah. So that means we have to be very careful with the times. So I told you the time is 250 this way and 250 this way. So what is the time here?
500 milliseconds.
No, because that's only half of a cycle. The time is for one full cycle.
500 milliseconds, so 0.5.
No?
How long is it?
250 milliseconds.
No, you're not thinking. Please think.
How long is the half of the
Here to here is how long?
200.
250. And here to here,
250.
50. That's only half a cycle.
So
500 1,000 milliseconds.
1 second.
1 second. So the time is 1.
Say that again, please.
Yeah, so look at the motion, okay? It goes like this. Back, watch again. 1, 2, and it stops.
Okay.
But that's not a full cycle. A full cycle is this. 1, 2, 3, and 4. That's a full cycle.
Okay.
So you only saw 2 quarters, half of the cycle. So 250, 250, but it should go 250, 250. But you never see that half. So the total is 250, 250, 250, 250, which is 1,000 milliseconds, which is 1 second.
Okay.
So the time is 1 second. That's difficult. But this is sometimes what happens in the exam. You have to read very, very carefully.
This is like.
Now maybe this is more difficult than the exam, yeah?
I didn't get it.
But you need to give me a question.
How is this one?
Yeah, so look here. How far from here to here?
250.
Here to here?
250.
Here to here? 250. Here to here?
But it doesn't go to.
I know it doesn't, but this is just like the example I did last time with the car that went around the corner. So I said here this took 2 seconds. So what is the time? Is it 2 seconds? Why is it 8? It'd be, 2, 2, 2 and 2, it'd be 8. Now does it travel the 8? No. But the time for one cycle still would be 8. It's not important that it did it or didn't do it. What is important is how long would it take if it did one cycle. You get, yeah. It's hard, I know. I don't even know what the question is. We're just getting the information. So what do I ask you to get here?
Potential energy.
Right, so what's the formula for potential energy? A half m
Omega squared and displacement.
omega squared
Yeah,
s squared. And I ask you for the potential energy.
and where does it come?
Yeah. So tell me, in the motion, It starts here, then it decompresses, and then later it would, compress and then decompress. When does it have all the potential energy stored in it? When it's compressed, yeah. So what is the S for that? Is it 0, 2, or 4?
It's
1.
2. 2. Yeah, 2. When it compresses to 2 centimeters, that's when all the energy is in it. And then what happens after that? It goes back to kinetic energy as it moves out. Yeah. So, do we have the M? We do. It's 100,000, is it?
Yeah.
And do we have the S? We do. It's 0.02. Yeah. And do we have the omega? We can get it. What's the formula for omega? 2 pi over
T.
T. And what's the T? 1.
So it's 2 pi.
Yeah, so it's 2 pi. So let's calculate this. I don't think anybody got this, did they?
No, I did.
Oh, sorry, and there's a square here. 789 joules? Or 0.6 joules? Yeah.
I got 790.
Yeah, but if you round it up.
But
It's-
I've done it like.
Mir, I'm so hungry for lunch.
No.
I don't have energy.
I'm not
Please,
talking about
have
this.
mercy on me. 790 joules. What are you saying?
I'm not talking
Oh, okay,
about
what?
round up. I'm talking that I have different values, but round up is coming same.
What do you mean you have different values?
Like I have got omega is 4 pi.
Yeah, so do I.
And I have the S 0.01.
Ah, okay, alright, you have the wrong numbers here, but you got the right answer. That's because you made two mistakes that cancel each other in this formula.
What are the
I
mistakes?
got-
Yeah, here.
I got.
He made this number twice as big as it should be. But he also made this number half the value it should be. So the errors, yeah, so the errors cancelled each other by accident, okay?
So I wrote this question.
Actually, it's the same for me because I did.
Okay, alright,
It's
fine.
not half, yeah. It's 2 pi over half.
Yeah.
Yeah, okay.
Okay, that's an accident, okay?
I wrote this and got the same answer. I got 789.
Okay, that's fine, Right. What's the next part then?
Where does it come from? Just
Yeah, where does this potential energy come from?
From the kinetic energy?
Yeah, it comes from the kinetic energy. So what happens is, look, the train is coming along, and it hits into the barrier, and the kinetic energy from the train becomes potential energy in the bumper. Yeah. In fact, you could work out how fast the train was going when it hit the bumper, because the kinetic energy of the train before it hits equals this potential energy. So let's see what that is, by the way. I'm curious. What's the M 10,000?
100,000.
100,000.
790.
Yeah, so the answer is a very small 13 centimeters per second. So, the train is maybe going like this speed. 13 centimeters would be this much. So the train is moving along at this speed. I guess it's pretty fast when it hits the bumper. Yeah. Is there more to this? Is there another part to this question? No. Okay. Yes?
A spring displaced a distance of 5 centimeters from its equilibrium will vibrate with a frequency of 2 Hz. How fast is the spring traveling after 0.7 seconds if it was displaced by a distance of 10 centimeters instead?
Okay. So I have a spring here, and I pull it down 5 centimeters, and the frequency is 2 Hz. And then in the second situation, I pull the spring down further. 10 centimeters is the amplitude,
0.7.
and I want to know what the frequency is.
Yeah.
So, what could we do here?
So this is going longer, yes?
Yeah, longer. Yeah. What do I want to know?
The area or the
I want to know the F, isn't it?
No, V.
How fast?
Oh, how fast is it going? Yeah. Okay, does anybody know what to do here?
T.
We could find the T first. In this picture, the T equals 2 pi over omega. Oh, sorry, no, T equals 1 over F. Sorry. T equals 1 over F, yeah.
0.5.
So it's 0.5 seconds here. Now, what's the T here? You don't know. Yeah. Now, here's the trick. This is an example of, what's wrong? Yeah.
How fast is the train traveling after 0.7 seconds?
Yeah, we still have to get to that part.
Oh, okay.
Yeah.
Okay.
So, here is the trick for this. This is actually an example of the forced harmonic oscillator. When a spring is moving, okay, you remember I said the frequency, the time, and the omega, they don't change. Even if you shake it more, or you pull it down more, it doesn't change. So this is kind of a trick. The frequency is actually the same, which means the time is still 0.5. Yeah, now we get V, now does it start on outside or inside? It's outside, so X, the S we use sine or cos? For S, cos. So for the V, sine. So the formula is A omega sine omega t. Do I want speed or velocity?
Speed.
So I don't care about the sine, it's speed. So what's the A? 10. The omega is 2 pi over t, which will be 4 pi. Sine 4 pi times 0.7. Omega is 2 pi over t, which equals 4 pi. Right, so what's the...
1.26.
3 pi to...
meters?
No.
This?
No.
No. Oh yeah, well, go on, say it. No, say it, go on, don't be shy. 3.42. Go on, multi. Now there's one more sound, multiply, yeah, multiply.
10 minus
10. What's this? No, squared, no, good try, no. What is it? 10
to the power.
Power.
Minus.
10 power minus 3 meters per
And-
second.
But I have got 1.26.
Did you do the sine or cos?
I did with cos. I thought.
Yeah. See, I did it with cos too. I went back to a spring is placed a distance from its equilibrium. That's outside. Yeah.
Why the
Yeah.
T is 0.7?
I give this in the question.
Yeah.
Flan, if you do not want to say multiply 10 minus 3,
Do the sine.
you could say 3.42 millimeters per second.
yeah.
Yep. Is there more to this?
No.
No?
But still the answer is changed.
Oh, let me check.
It's
Maybe I
minus
shouldn't
0.01.
trust Flan then.
Or me.
Or you.
Radian.
Or both.
Oh!
Radian.
Oh! No,
I
Flan.
think her
No.
calculator is in
Radian mode. Yeah.
It's not.
We should be in radian mode.
Yeah, it should be.
Hers.
Show me your calculator. Show me.
Just for.
Show me.
Sorry.
It is in radian mode. No, it is.
Okay.
So when I type this in, I get, what did you get?
0.016
No, I didn't get that either.
or 1.26.
No.
I've got 4 answers.
I got 0.
Yeah.
5 sine.
I mean 4 pi is 12.8.
Here, this is in, it should be like this.
0.7. No. See, don't do that.
Like
Don't
this.
do that. Just write 4 pi.
Oh.
Just write 4 pi.
The
Don't
T
do
is
that.
inside.
4 pi is this. No. Just
Because look,
Wait, what's the time? 0.7 or
Yeah.
0.75?
7.5.
In the question.
7.
7.5.
7.
0.70 seconds. She thought the S was 5 probably.
Now. Yeah,
I
okay.
also made the mistake. Instead of time, I've written to 0.7. That is why.
Oh my god.
0.1.
It's okay.
12.5.
Did I have a space between the 7 and the S? Or, I did have a space, okay.
12.5. Multiply by 0.7.
Read carefully.
Yeah.
Okay. Continue. Is that the end of this one? Yeah. Yeah. Okay. Can I close this? Yes.